It's me, Deepa. I'm back with another theorem, important theorem, midpoint theorem of class 9 CBSE syllabus. The midpoint theorem states that the line joining the midpoint of two sides of a triangle is parallel to the third side and is half the length of the third side. So we are going to prove the midpoint theorem, and let me explain the theorem to you. You can see a triangle over here, triangle ABC, and D is the midpoint of the side AB, and E is the midpoint of the side AC. Since D is the midpoint of AB, we know that AD equal to DB, and E is the midpoint of AC, so AE equal to EC. This much we have in the figure. Now our theorem states that this line D, the line joining the midpoints of the sides AB and AC is the line D. The line D is parallel to BC and it will be half of BC. So in order to prove the theorem, let us draw CF parallel to BD. Draw CF parallel to BD, and to prove DE parallel to BC and DE equal to half of BC. In order to prove DE parallel to BC, what we are going to do is that we are going to prove that the quadrilateral BCFD is a parallelogram. As you know, the opposite sides of a parallelogram are equal. So once we are able to prove that quadrilateral BCFD is a parallelogram, we could say that DF is parallel to BC and eventually DE will become parallel to BC. So our aim is to prove that quadrilateral BCFD is a parallelogram. You have already learned a theorem that if in a quadrilateral one pair of opposite sides are equal and parallel, then it will be a parallelogram. So by construction we already have CF parallel to BD. Now what remains is that we have to prove that CF is equal to BD. So triangle, we have two triangles over here, triangle ADE and triangle CFE. We are going to prove that triangle ADE is congruent to triangle CFE. Then by CPCT, corresponding part of congruent triangles, we will say that AD equal to CF. Now already AD is equal to BD, and if AD is equal to CF, then we could prove that BD equal to CF. The opposite sides are equal and they are also parallel. So we could say that the quadrilateral BCFD is a parallelogram. So in order to prove quadrilateral BCFD a parallelogram, what first we are going to do is we are going to prove that triangle ADE is congruent to triangle CFE. To prove triangle ADE congruent to triangle CFE. As you can see in the figure, the Z shape, you can see in the figure the Z shape. AB and CF are parallel lines and AC is a transversal that cut the parallel lines AB and CF. So angle DAE and angle FCE forms alternate interior angles and hence they are equal. Angle 1 is equal to angle 2 as you can see in the figure. Then one angle already you got to prove the congruency. Now look at the next figure. Angle 3 and angle 4. As you can see, AC and DF are two straight lines crossing each other. So angle 3 and angle 4 forms vertically opposite angles. And so they are equal. Vertically opposite angles are equal. Angle AED equal to angle CEF. And also E is the midpoint of the side AC. Therefore AE equal to EC. Now we have got two angles and the included side. Thus we have proved that triangle ADE is congruent to triangle CFE by ASA congruence, angle side angle congruence. Hence by CPCT AD equal to CF, corresponding part of congruent triangles. Now we have proved that AD is equal to CF. Already AD is equal to BD since D is the midpoint of side AB. Now we can see that AD is equal to CF and AD is equal to BD. The left hand side is same, so right hand side should also be equal, that is CF equal to BD. So what we have proved? We have proved that already CF, by construction CF is parallel to BD. Now we have also proved that CF is equal to BD. So by the theorem, if one pair of opposite sides of a quadrilateral are equal and parallel, then the quadrilateral is a parallelogram. We can say that BCFD is a parallelogram. Hence, DE parallel to BC. Since E is the midpoint of DF, we know that DE equal to half of DF. And DF is equal to BC. The opposite sides of a parallelogram are equal, as you know. So DF is equal to BC. So we can replace DF by BC. So DE equal to half BC. Thus we have already proved that DE is parallel to BC and DE equal to half of BC. And hence the proof. Thank you.